First, we have to introduce myself. I am P. Mubina. I am from AAA section. Subject name Physics. Subject code 23 PHY01. And my topic is direct and indirect band gap semiconductors. Direct and indirect semiconductors. The real band structure in 3D is calculated with various numerical methods. The lattice is assumed to be a perfectly periodic lattice. The space-dependent wave function is assumed to be a plane wave. The allowed energies E are plotted vs K. K is called the wave vector or propagation constant. For electron transition, both E and P must be conserved. P equals to hk. P is momentum. Direct and indirect electron transition in semiconductors. In semiconductors, direct transition with accompanying photon emission, indirect transition at defect level. A semiconductor is direct if the maximum of the valency band and the minimum of the conduction band have the same K value. A semiconductor is indirect if the maximum of the valency band and the minimum of the conduction band do not have the same K value. Variation of energy bands with allow composition. Variation of direct and indirect condition bands in AIG as a function of composition of a GAAS showing the three minima in the direction conduction band. Charge carriers in semiconductor electron and holes at 0 K. A semiconductor is an insulator with no free charge carriers at T greater than K. Some electrons in the valency band are excited to the conduction band. The electrons in the conduction band are free to move about many available states. The empty state is the valency band is referred to as a hole. The concept of hole. A hole is an imaginary positive charge moving in the valency band. The energy of hole increase download in a normal band diagram. The total current flow in a semiconductor is the sum of electron current and hole current. A valency band with all the states filled including states J and J marked for discussion. The jth electron with wave vector Kj is matched by an electron at J with the positive wave vector minus Kj. There is no net current in the band unless an electron is removed. For example, if the jth electron is moved, the motion of the electron at J is no longer superposition of the E, K. Band structure on the E versus position. Simplified band diagram for a semiconductors in an electric field. Electron energies increase going up while hole energies increase going down. Similarly, electron and hole wave vectors point in position directions and these charge carriers move opposite to each other as shown. Effective mass. The effective mass of an electron in a band with a given E, K relation is defined as m equals to h square by d square E by dk square. For free electron, E equals to 1 by 2 mv square equals to 1 by 2 p square by m equals to h square by 2m k square. M square equals to m. The effective mass is inversely proportional to the curvature of the band. The electrons near the top of the valency band have negative effective mass. In general, M product is different in each direction and is a tensor. Approximate average are needed for various calculation proposed. Density of state effective mass is conductivity mass effective mass. The introduction of M's product will be simplified calculation. Electron effective mass is denoted by Mn product. Hole effective mass is denoted by Mp. Intrinsic semiconductors is perfect semiconductor crystal with no impurities or lattice defects. N conduction band electron concentration electron per centimeter cube. P valency band hole concentration. N equals to P equals to Nt. Ri recombination rate of E HP GL generation rate. N dot P dot equals to concentration and equilibrium. A alpha constant. R equals to alpha 1 n dot p dot equals to alpha n p square equals to gi. Extrinsic semiconductors. A doped semiconductor crystal hole equilibrium carrier concentration N0 and P0 are different from the intrinsic carrier concentration Ni. For Si and Ge, group 5 elements such as P, Sb are donor impurities. Group 3 elements such that B, I, Ga and in are acceptor impurities. Conclusion. This is possible in a direct band gap semiconductors. If the electron has k vector near the conduction band minimum, the hole will share the same k vector, but no possible in an indirect band gap semiconductors, as photons cannot carry crystal moment would be violated. Thank you. And signing off, P. Mubina.